Okay, so we covered 45, 45, 90s, and then the other special right triangles, 30, 60, 90. Where did those come from? This is going to be a lot harder to draw, freehand for sure, than a square. 30, 60, 90 triangles all come from or originate from an equilateral triangle. Oh, dang, that's pretty good. Equilateral triangles, if you recall, every angle is 60 degrees. 60, 60, 60. Every side is congruent. So, let's say, I say that this side is 8. That means all the sides are 8. Yeah? So they come from an equilateral triangle. Equilateral, or you could say equiangular. Say it has similar meaning. Equilateral triangle. And with squares, remember we drew the diagonal, which is from one vertex to another vertex, and that splits the square into two congruent triangles. Well, if you draw, this is called the altitude, and the altitude does a couple things. One, it is perpendicular, so it forms a 90-degree angle here and here. It also bisects this side. Bisect means cut in half. So if this whole thing is 8, then each piece is 4. Yeah? And that would leave us with just one unknown side right here. I'm going to call it X. No, I'm going to call it Y this time. We used X a lot in the last lesson, so let's use Y. Yeah? Let's figure out what Y is. The exact length, not the approximate length. Obviously, we could tell with your eyeballs. It's bigger than 4. And you can also kind of tell with your eyeballs that it's smaller than 8. So it's like, imagine if this was a pivot point and you swung this thing over, it would hit about right here. So it'd be like 7 point something, 6 point something. We don't know. We're going to find out. So, let me cover up. Let me cover up half the triangle. So we're only looking at half of the triangle. That is me, senior year, high school. Point defiance, by the way, in case you're curious. Oh, one thing I forgot to say. So this angle up here was 60 degrees. It also got bisected. So it is now 30 here, 30 here. So that is a 30-degree angle. 90. This one has to be 60 because they add up to 180. Okay. So we have 4 squared plus y squared. 4 squared plus y squared equals 8 squared. That's 16. Just like on the previous lesson, we're going to go through 3 examples. I'll show you the work, and then we'll use that pattern to actually do the assignment. You won't have to show any work. You can show work like once if you want. Chloe did that, so that made me happy. Subtract 16 on both sides. But the reason why, believe it or not, I don't want you to show work is because we're going somewhere with all this knowledge. Yeah, and it doesn't have anything to do with the work. It has to do with something called the unit circle. That is our end goal with trig. We're trying to get to that point. So this week and last week and the week before that and the next week and the week after that, it's all leading up to something. 48. So this is going to be a little bit harder than squares, but I will say this. every time you're dealing with a 30, 60, 90, it's a special right triangle. The special number you're going to get is radical 3. So that is a massive hint. Whereas special, nope, sorry. Aha, the 45, 90s, this is a special right triangle, and the special number that you always got was square root of 2, every single problem. This one will have a special, or a square root of 3. So I'm going to do the work over here. 48, I'm telling you that it breaks up into 2 pieces, and one of those pieces is square root of 3. So you just divide that by 3, and you get 16. And then the square root of 16 is 4, so you get 4 times the square root of 3, 4 times the square root of 3. That's how long that side is. Now, my prediction was 6 point something or 7 point something. That's the exact answer. What I'm about to get on the calculator is approximate answer. So 4 times the square root of 3, I'm going to go 7.2. Dang it, 6.9. So I was close. By the way, square root of 48 is exactly the same. Why? If we're saying that they're equal, then they better be equal. Yeah. Okay. Next example. Remember, we have to see a few before we can jump to conclusions. Dun, dun, dun. I'm going to draw. Oh, shoot. I should not have started with the diagonal. But since I already did, and I'm doing it in pen, voila. See how good this turns out. Oh, snap. I said that was 8, so let's say this is 12. It's a little bit bigger, so I'm going to say it's 12. Dun, dun, dun. So that's 12. This is 12. This is 12. This makes that 6. That 6. This is a 30. This is a 90. This is your 60 down here. I don't need to put it because it's obviously 60. And then I'm going to call this y again. And then I'm going to cover up half of that because I'm only concerned with the 30, 60, 90 triangle. 30, 60, 90. And okay, keep that covered up, sorry. 6 squared plus y squared equals 12 squared. 6 squared plus y squared equals 12 squared. That's 36. That's 144. Subtract 36 on both sides. Subtract 36 on both sides. You get y squared equals 144 minus 36. Oh, no, wait. Oh, that's a familiar number. It was on one of the previous assignments. Square root both sides. Those cancel. Okay, and I'm going to do the work over here. Again, I know, because it's a 30, 60, 90, that one of the special numbers involved will be radical 3. So you just divide 108 by 3 to get this number. 108 divided by 3, 36. Which happens to be a perfect square. Yeah, and then square root of 36 is 6. So this ends up being 6 radical 3. I'm going to take a guess. That's 12, so it's going to be 11.2. 11.2. 6 times the square root of 3. Dang it. Not even close. Not even close. Dang, I should have looked here instead of here, because I know that the square root of 100 is 10, so this is only going to be a little bit bigger than 10. Yep, I'm an idiot. I looked here. I should have looked here when I was estimating. Yeah, same thing up here. Like I know the square root of 49 is 7, so the square root of 48 is just below 7. Sometimes you just don't think. One more example. This is going to be small. I'm going to call this 2. Here you go. 2. That means this is 2, which makes each of these little pieces 1. And voila, shoot. This is 30. That is 60. This is our unknown. And I'm going to do the work over here. So we got 1 squared plus y squared equals 2 squared. 1 squared plus y squared equals 2 squared. 1 squared is 1. 2 squared is 4. Subtract 1 on both sides. Cancel. We get y squared equals 3. And, well, this one's going to be easy, huh? Square root both sides. Square root both sides. I picked a bad number. Shoot. Y equals, square root of 3 is just square root of 3. But I'm going to put a 1 in front of it just so you guys see the pattern. Yeah? So let's talk about the pattern. Small side is 4. I'm going to call this the medium. Small, medium, large. Small, medium, large. Small is 4. Large is twice as big. That's true every time. Small, large is twice as big. Small, the large side is twice as big. True every single time with the 30, 60, 90. We're at the 12-minute mark, so I'm going to continue this video in a second. Yeah?